Hi, sir. Good morning.
Hello, Sachin. Good morning.
Hi. So we'll wait for another 2 to 5 minutes. Kapil is already enrolled for the session, and a few enrolled students are joining the session. Okay, sir.
Oh, yeah, sure, sure.
Mm. And you can end the session by after the class. You can end the session. Okay.
Yeah, yeah, yeah. So, do I need to start from the scratch again or can continue with what I have started?
You can just you can give the introduction of the previous session, like what we have covered already, and then you can start with and then you can continue. Okay.
Okay, sure, sure.
Thank you. Good morning, sir. Hello. Vivek, sir, am I audible?
Hey, yeah, good morning. I'm audible, yes.
Okay, okay. So we can start the session.
Okay, sure.
Okay.
Kunal will be joining today or? Oh,
Yeah, he will be joining within 5 minutes.
okay, sure. Okay, so in the previous class, no, the last week, we tried to understand um, what are the different type of network that we have, LAN, WAN, MAN, and all. And we try to understand what are the typical topologies that we have. We have bus topology, right? We have star topology, mesh topology, hybrid. We have a glance in that how it works. We also try to look what are different type of networking device that we have in our environment, in networking environment. We have routers, we have switches, we have APs, we have WLCs, we have core switches, routers, firewalls, load balancers, right? So these are all the components that we have in our networking environment. We looked into that. Now we looked into the how the device is getting booted up in a Cisco router. Right? So what are different components that we have? We have the NVRAM, we have the RAM, ROM, we have the flash wherein the configuration is saved, right? And there your iOS is present. So all this was looked into. And then finally we went towards what is IPv4, what is IPv6, and then the basic kind of fundamentals of what is IPv4, IPv6. And then we looked into how the MAC address is, what is a MAC address, right? So we try to understand that. Now today's session will just try to understand how the IPv4 is and how the subnetting and supernetting is happening in the IPv4, right? So as the last class I told, IPv4 is having 32 bits and each octet is of 8 bits, right? So 8 into 4, we have around 32 bits, correct? So we'll just try to see how the subnetting happens in um, the IPv4. So, but before that, we also need to understand that IPv4 is typically been segmented with the help of subnet mask, right? We have subnet mask with which we identify which kind of um, subnet the IP address belongs to. Okay, just for reference sake, I'm just adding it here. So this is class 8 subnet of /8. Right? So ideally, we have this. This is something that we are typically using /8. Then this will be /16. This will be /24. Now, in the previous class, we also know that an IP address will be having two things. One is your network and then the host, right? So how are we trying to understand what is network and what is your host IPs, right? So we are using something called, with the help of this um, subnet, right? This subnet specifically is trying to differentiate which one is your um, which one is your network and which one is your host. Now, considering this as your IP 10.1.2.3, now if I'm using /8 here, so this guy is your network 10.0.0.0. That's your network. Okay. Now, what if we have a /16? Now we'll add one more octet that is of 8 bit that becomes /16, and this to 10.1 becomes your network. Now what will happen if you add one more bit into your IPv4? So this bit is in your a bit in your network segment now. So 10.1.2 is a network, and the last octet becomes your host, right? So that's how we have segmented it, right? So when you say, if for the new folks who just joined today, so if you were a bit confused on what do you mean by 225, 255.0.0.0, it is a notation in which we are just trying to identify which one is in network and which is in host, right? So in an IPv4, you will be having um, your network ID. Okay, this will define that what all IPs are present in the specific network. Okay, there will be a set of IPs. There will be one, two, three, something like that. They're based on the network, right? So in that network, right, to identify if it is a specific subnet, right? So in an IP address, in a pool of IP or in a network, you'll be having one your network address. You'll be having one broadcast address. Okay. So what is your broadcast address slash 8? You're just making 255. Okay. You're just flipping uh that last octet 0 and 0 and 0, right? You're making it to 255, 255, 255. So ideally it means is if you're looking at this specific IP and it is slash 8, so 10.0.0.0 slash 8. That's your network. Okay. Now, what we're trying to do is we want to find this broadcast address. So what we do, a broadcast address will be you just adding 255 on that 0. Likewise, that 255 again. So 10.255, 255, 255, that's your broadcast. Now, now in that network ID of 10.0.0.0 slash 8, you cannot use your network and broadcast. Okay, anything apart from that you can use, right? So you know, you're now aware that what is your network, what is your broadcast address. Now, what we're trying to understand, what is your first IP in your network? That is what we're going to understand today. Okay, how we are trying to achieve that. So first thing, subnet mask is used to identify which is your host, which is your network, right? The network will be what, wherein you will having this in a subnet of slash 8, wherein you have 255. That octet becomes your network, okay? And zero zeros, those becomes your host. This is the easiest way to understand it, okay? Now, out of that, which is your network ID, 255 to zero zeros, that's the subnet. Now, you just need to flip the zeros into 255. I mean, sorry, the IPs, the the so the starting IP address will be your that subnet that first octet number, that is 10, and then rest all will be 0 slash 8, right? Now, in the last one, to understand which is the broadcast, you're just flipping the zeros to 255 of that IP. That is 10, 255, 255, 255. That how it becomes. Now, this is for slash 8, right? Happen for this guy. So, keeping this as our example, so this 0 will become 1, okay? And this 255 will go to, will be replaced with 1. So, this, so 10, 1 and 10, 1 will be same here, right? Because that is constant. It's not changing. That's the reason we are calling it as network. So in that case, 10.1.0.0 slash 16 will be your network. 10.1.255 will become your broadcast, right? Similar way, with respect to slash 24, what will happen is your IP is 2, right? This will be put into 2, right? And this will be also made it to 2. Okay, so 10.1.2.0 slash 8, that becomes your uh, network. And out of that, 10.1.2 is your network, and your broadcast will be 10.1.2.255, right? It's just a refresher part since it's a week, just trying to refresh what all the stuffs are. So hope um, this point was clear, at least the subnet and host part, host and network part, right? So now that we understood what is subnet, oh, sorry. Now that we understood what is subnet and what is host and what is network out of it. Now you might be thinking, how come we got to know that value 8? Okay. Now that value 8 comes basically each octet is of 8 bit. Okay. 8 bit. So what 8 bits means? Now you're breaking down the IPv4 address. Your IPv4 address of one octet will be having 8 bits. That is 8 binary bits. Okay, that will be either it can be ones or it can be zeros. That is what is depicted here. You have having the value is 10, right? You have converted this into what? 0, 0, 0, 0, 1, 0, 1, 0. That's your value 10. Okay. Now, now your question is, how did we got that 10 value? Okay, and how did we convert that binary? We'll look into that. Now, prior to that, you need to understand that each octet has 8 bits, and when it has 8 bits, okay, so that's why whichever it is constant, right? So this is constant here. That is network is constant. That is slash 8, it has to remain same. So this bit will be remain same for all the network. That's why it is slash 8, because 8, 1, 2, 3, 4, 5, 6, 7, and 8 bits, right? Same like that. Now, when we move to slash 16, you will add up 8 plus 8 bits. Okay. That's how you're getting your slash 16 here, right? Now, what we'll do when you move to slash 24, you're just adding another bit of 8 bits. This octet of 8 bits plus 8, that becomes 24. Now, you might be asking, what if we do this? Then it becomes your broadcast address. You cannot use the broadcast address. That is 255, 255, 255. Okay. Entire thing is to consume. So that is your broadcast address. So that we cannot use. So the usable IPs in an IPv4 is of slash 8, slash 16, and slash 24. Okay. Out of that, your network and broadcast cannot be used. Rest all the IPs can be used. Okay. Now we know that each octet has around 8 bits, and combined together, okay, it will be having 32 bits based on slash 8. 8 bits is consumed. That becomes network. Slash 16. 16 bits are consumed in 2 octets. That is constant. And in slash 24, 3 octets are consumed. That is of 24 bits together. Okay. Now our intention is, okay, we now know what is host and network and all these things. We know, okay, this is pretty simple that each octet is of 8 bits. Now our next intention is like, how do we got to know that this guy is 10, and how are we converting this into binary? Okay, so you're all, if you're very well versed with, well good. For the folks who are new, we'll just try to summarize this thing how it is, right? Now, so if you so in IPv4 conversion to decimal, we need to understand we have some values called like this. Just memorize this, is very simple. 128. Okay, we'll start from left to right. Okay, so 128 divided by 2 is 64. Okay, divided by 2 is 16. Divided by 2 is 8. 8 divided by 2 is 4. Then 2, right? Then 1. Or is it 0? Sorry. Yeah, 1. So this will be 1 here. Sorry. So you type it here. 128, 64, 32, 16, 8, 4, 2, 1. Now, this is your cheat code to understand how we are trying to try to make that number into binary. Okay, we'll just take one live example that we have in our next slide. Okay. Okay, so here it is already there. Now, now we have a number of 150. Okay. Now we need to convert this into decimal, right? Or the zeros and ones. Now, how are we going to do it? Our fundamental is any number greater than or equal to. That is what we need to check. Okay, our number is 150. We need to convert this into ones and zeros. Now we know that answer is 100 10110. Okay. Now how do we achieve that? That is the question, right? 150. So is 150 greater than or equal to 128? Oh yeah, it is, right? So what we do? We'll just mark it as 1. Okay, what is my pen? Yeah. We mark this as 1 because 150, okay, but I'll take the text. What is happening here is the first part 150 minus 128. Okay, 150 is greater than 128. Yes. Is it equal to? No. But the formula it matches, right? So 150 is greater than or equal to 128. So what we do? We just minus 150 minus 128. Okay. The value we get is around 22, right? So 128 plus 22 is what? 150. Okay. So we know that since our first parameter matches, okay, we just give it 1. 1 here. We just give it 1. Okay. What about our next guy? Is 22 greater than or equal to 64? No. We give it a 0. Okay. Now we go into next bit. That is 22 greater than or equal to 32? No. We just give it 0. Okay. Now our next question is this guy. Okay. Is 22 greater than or equal to 16? Yes. We give it a 1. Okay. Now what? 22 minus 16. How much it is? It will be 6. Right? So is 6 greater than or equal to 0? No. Just give it a 0. Is 6 greater than or equal to 4? Just give it, yeah, it is 4. 6 is greater than 4, right? So what we'll do, we just give it a 1. Okay. Then 6 minus 4. Okay. What it is? It will be 2, right? So here we have now 2. 2 is greater than or equal to 0. Yes, it is equal to 0. Sorry, equal to 2. We just mark it as 1, right? We don't have any more values here. So we just give it 0. Okay. That's your decimal. 100 10110. Make sense, guys? Any doubts, any concerns for the new guys who just joined? Kapil, what about you? Kapil, Akram.
All good, sir.
Yeah.
Okay. Okay. So now we know we have converted this into binary. Let's look at the next part. Okay. Now this becomes very important. This is, I mean, as a network engineer, you will not be doing any kind of binary conversion. Okay, you by on your own. It's just that as a network engineer, you need to understand the basic stuff, how you are achieving that. Tomorrow, if someone asks, can you tell me how that binary is getting converted? So you should be having some answers, right? So that's the reason I'm just sharing. Okay. Now what do we have in the next slide? Let's see. Okay, we just try to do that same thing. Okay. So here we have a value of 167. Okay. Let's see. 167. Let's just verbally try to understand what it says. 167 is a value. Okay. Is 167 greater than or equal to 128? Yes. So we mark it as 1. Okay. So 167 minus 128. What is the value that we're getting? We're getting 39. So 39 is a pending number that we need to look into. Now we go to next guy. Is 39 greater than or equal to 64? No. Then in that case, it is 0. We just carry forward to next bit. Is 39 or equal to 39 greater than or equal to 32? Yes. We mark it as 1 over there. Okay. So 39 minus 32, what we're getting? 7. Now again, that information carries over. Is 7 greater than or equal to 16? No, we mark it as 0 over there, right? Is 7 greater than or equal to 8? We mark it as 0, right? So what will happen? 16 and 8 will be 0. Now again, is 7 greater than or equal to 4? So 7 minus 4 is what? 3, right? 3 is pending now. So we mark it as 1 over there. Is 3 greater than or equal to 2? Yes. We mark it as 1 over there. Okay. Now the last one is 1 greater than or equal to 1? 1. Yeah. So we got the binary number as 101001111. Intent is that you just need to minus it with your corresponding number from left to right until you get it to 0, right? Whenever you get that 0 value, you just stop it from there. Okay. Now you know how you are trying to convert convert an IP into binary. Now again, the flip side. Now there will be situation that you need to convert your binary into IP, right? Now again, this is just a theoretical perspective. You will not be working on your real world environment that trying to convert your binary and numbers to binary. It's just that you need to understand how the IPv4 conversion happens. That's the reason. Okay. Now our next point is, right? You have got a set of binary numbers, right? How do you, sorry, let's try to check, move this thing. Okay. How do you try to make those binary into numbers? That's our question here. Very simple. You have your cheat code 128, 64, 32, 16, 8, 4, 2, 1. You got the binary numbers, right? You just directly map it one to one. So what happens here is we have a binary number of 0, 1, 0, 1, 1, 0, 1, 1. And what you do, you just map your numbers here. The first bit is 0, second bit is 1, third bit is 0, fourth and fifth bit is 1, 1. Then the sixth bit is 0, 7 and 8 bit is 1, 1. Now what you do, you just add the values wherein you have 1. That is 64, 16, 8, then 2, 1. Now when you add all this, the sum of all value is 91. So the number is 91. Pretty simple, right? This should be fairly easy. If you understand the first part, this is like a cakewalk. Can I see some thumbs up here? If you understood all this. What about Kunal? Akram, good? You should be good.
Yes, sure.
Yeah, cool. Right. Now, we understood the binary conversion, right? We understood how we are converting a number into a binary into number, right? Let's just try to understand what happens in your real world environment. Okay. Now the binary, the 10, 1, 2, 3. Okay. Our binary number is what? Our binary number is 10. Here we gave 0, 0, 0, 1, 0, 1, 0. Okay. 1, 2, and 3. We have gave the binary numbers according to that, right? Now what happens? You just consider this as a /8 subnet. What you do? You just move that /8 subnet, that is 255.0.0. You're converting. So 255 means your all bits in that octet is consumed, right? Oh, sorry. So all bits in that octet is consumed. So that subnet, you have put that value over here. Okay, right? So this is what is actually happening. Uh, this guy, you're not changing anything. right? And all the next three uh, octets, you put it to 0. That is, this can be changed. So what I'm trying to say here is, when you sum up all these things, you get to know 10. Okay. So what is actually happening is, there is something called XOR or add. Add operation happens here. What is, or AND operation actually. So what it is, 0 into 1 is 0, 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 1 into 1, 1. Okay. 1 into 0, 0. Okay. 1 into 1, 1. 1 into 0, 0. Okay. So what happens? Ultimately, you'll get the same value. Okay. Any number multiplied by 0 is 0. Okay. If two numbers, if you multiply 1 with 1, you get to value 1. Right. So that is what is happening. You just try to, 1 second, just take my pen. So just look at it like this, 1-to-1 mapping. Okay. 0 into 1, 0. Okay. Again 0. Okay. Then again, this third octet, 0. Sorry, third uh, binary number, fourth binary number, 0. Okay. Now 1 into 1 is 1. Okay. 1 into 0 is 0. 1 into 1 is 1. Okay. 1 into 0 is 0. Okay. Now the next, so this is your network part. Okay. So you found your network, and that is same after AND operation. Okay. Now what happens here? Zeros into all this is 0. Okay. Again, everything is 0. Okay. Here, sorry. So here it is 0. Here it is a big 0. Okay. So what happens? After your AND operation with your subnet, you're getting what? Your network, right? That is your network. This is your network ID. That's how you create a network ID. Previously, I said the shortcut way. Now, this is how what the operation is happening. You're just doing an AND operation. And what is an AND operation? You're just trying to multiply with that subnet or the octet or zeros and ones with each other. Okay, as soon as you do that, you're getting it. Now, what do you mean by AND operation? There are certain operation that happens in the Boolean, okay, or the binaries. Okay, one is your AND operation.
And
Okay,
just a question, Vivek. How did
yep.
we get subnet mask binary numbers over there?
So this is something fixed. Okay, or you can say that this is a fixed thing that you're trying to understand, because in the private IP you only have this much IPs, that is /8, /16, and /24, that you can use in your network. Okay. Now, based on that, what we're trying to do is, you have around, um, you know, how you come to subnet mask, because this is what we have in our private IPs that can be used. Okay, that's why we are trying to learn this. Okay. Now the intention is that, can we go less than this? Probably not, because we'll not be able to go beyond /4. We cannot go, because you're trying to identify your subnet. So the first thing is your subnet. So the first thing that you need to understand in subnet is that we have only three types of subnet: /8, /16, and /24. There are many more, but those are not being used in your private environment, right? We said that private is something that is internal to your infrastructure, and this is not routable outside of your public address. Okay, this present resides in your environment. So these three are present in your network. So now to identify that, we are using it. Okay. So initial start value is of 8 bit. So you start with 8. That's how it is. Start with 8, and then you add another complete whole bit. When you're adding it, becomes 16, and then you add the complete another one /24. Now in between as well, in /8, you can just borrow 2 bits from this guy. So assuming that you need to borrow 2 bits from this guy, okay, you add that bit, then becomes /10. Okay, now you can borrow this 2 bits from here and make it a network, And what will happen is you 10 what is 8 plus 4 12 bit, you can do that. That is what we called as subnetting or supernetting, we can see that. Those are the term that happens. Okay, but by default, this is your parameter. This is your what you say, your formula, or this has to be, like imprinted in your head. Someone has Kapil, can you please mute yourself?
Sorry.
Yeah. So this is what the subnet, the subnet I just gave you, this is what is be used fundamentally, okay, to identify which kind of subnet you're working on. Based on that, you're either adding or subtracting. Okay, that's how it is. Now, what I meant by the AND operation is basically that typically to find the your network. Okay, so any IP address will be having network. So how do we find that? It is just based on that. So any network, okay, if it is /8, you just put it over here, okay, on that IP address and try to multiply that values, you will get your network. Okay, now what happens is, so again, if it is /10, so till here, right, this will value will become 1 1. Okay, now based on that, your values will also change. Okay, we'll look into that coming ways. We'll just try to understand that how it is been done in coming slides. But at least you figure out the way, right? The how we are trying to calculate network from your IP address with your binary conversion. This thing is clear, right? You're just mapping this IP. Based on that, you're converting those IP address into binary, numbers into binary, and then you multiply that subnet with your um, what do what do you call this? The subnet mask. Now, the value you get, that's your network. Okay, this is the network I talked about. Okay, so what will it will be? You will got the network of 10.0.0. Now, how did you finding the subnet mask? You just that is uh, this will become zeros. So in this case, right, you need to find the what? You need to find the broadcast of this, right? What you do, you just flip this. So this will become complete zero. This will become 1, 1, and 1. So 1 as in all 8 bits are 1 and all bits are 0. Okay. Now what you do, you just add those, you will get this value same. So XOR operation is happening. Then that's when you are trying to uh, add those. If in XOR operation, if it is 0 on 0, then it will become 0. 0 plus 1 is 1. Okay, 1 and 1 is 1. So that's how that is working in XOR operation. So what happens here? You're just trying to do an XOR operation. Then what you get a value of 10 here. Okay. Then what it is? Everything, everything is 1 here. Okay. Then it will be 255, 255, 255. So entire thing will be 255. So by means of XOR operation is 1, 0. It is what? 1. Okay. 1, 1. It is 1. Okay. Now, only in case of 0 and 0, it will be 0. Okay. Since our entire bit is 1, you're likely to get the answer of 1 only. You will not get any kind of answer 1. Okay. That's what. So that's what I was trying to say about the operation, that is AND operation, addition operation. AND operation is what? 0 into 0, 0. Okay. 0 into 1, it is what? It is 0. Okay. Now, 1 into 0, it is 0. Okay. Only in 1 into 1, you will be having a value of 1. So while finding the values for network, right, what did we do? We just multiply this. That is the AND operation, right? 0 into 1 is 0. 0 into 1 is 0. Only 1 into 1, we made it to 1. So the entire value you got is as 10.0.0.0. Correct? That's your network. Now, in case of your finding the broadcast, what you're doing, you're just making it as the XOR operation. And what is XOR operation? That is 0, 1, your value is 1. Okay. Now 1, 0, your value is 1. 1, 1, your value is 1. Okay. And then, I'm sorry, not the XOR operation, your addition operation actually. And then in the last part, on 0 and 0, it will be 0 alone. Okay. So you're just adding all these things, you're getting that value, right? Now, now you know that how the, I mean, till here it is clear, guys. Let me just confirm whether it was XOR or add operation. Yeah, this was add operation. Sorry for that. Not XOR operation, add operation. Add operation 1, 1 will be 0. Yeah, add operation. Sorry for that. So now at least you got to know that how you're finding the subnet mask and network. Sorry, not the subnet mask, the network and the broadcast mask. That is the first one. Finding the network is AND operation, and then um, the other one, the is by adding it. That's how it has been happening. Is it clear, Kunal, Mohammed?
Vivek sir, a bit confused. I think I
Okay,
just need to go back to the books, right, and just revise it.
this is something present in back in engineering thing. That's why.
Yeah.
I'll just make it simple here. So AND operation is what? 0 into 0, your value will be 0. Okay. This is your AND operation. Okay. I'm talking about the AND operation. Now, 0 into 1, what will be your value? It will be 0. Okay. Now, 1 into 0, you'll be having value of 0. Okay. Only in case of 1 and 1, you'll be having a value of 1. This
Yeah.
part is clear. This part is clear, right?
Yeah.
Yeah. So what, based on this, now I have this IP address of 10.1.2.3. Okay. I have already marked it out. I have the binary. I have the binary numbers here. Okay. Now I'm trying to figure it out if it is of /8. What do you mean by /8? /8, your first octet is constant. That is, all your bits are consumed there. It is 1111. Correct?
Yeah.
So what does that mean? So 111000. So this is your subnet mask here, right? Your
Yeah.
intent is you need to find the network ID based on. So you have the IP address. Okay, you are now trying to figure out what is the network ID of this guy. I have the subnet mask. Okay, now I need to figure out what is your network ID of this /8. Now, how you do it is the question. So you need to find your network ID. We're just trying to do the AND operation. Okay, so what it is? The AND operation of the first octet, let's see that once again. 0 into 1 was what? 0. Second also, 0 into 1 is what?
Zero.
0. Right? All and what, just till here it is same, right? 0, 0. Now what? 1 into 1 is what? 1.
One.
Yeah. So 1 into 0 is 0. Then 1 into 1 is 1. Right? So what it means is whenever you do an AND operation, typically you will be getting the same number here. That is, this will be the same here. Okay. Now, since everything is 0 here, okay, what you will get 0 only. Right? So that means your network is 10, 0, 0, 0. Is this part clear? Network
Yeah.
part?
Yeah. Yeah.
Okay. Now that we understood this, now let's try to understand how the addition operation happens. Okay. Same thing, 0 into 0. 0 plus 0 is 0. Okay. 0 plus 1 is 1. Okay. 1 plus 0 is 1. Okay. Now 1 plus 1 is again 1. That is what is all about your
Mm.
addition operation. Okay. Now what happened in this case, right? You're trying to find the broadcast address now. So that is the last IP address of that network. You find the network. Now you're trying to figure out what is the broadcast IP address. Okay. Now what you do again, just trying to add the stuff up. Okay. Ignore this part. We're just trying to figure out this guy here. Okay. Now what is happening here? This is constant, right? So here we're just trying to add it. What we'll get? Everything. So here we are trying to flip it off, right? So we'll get zeros. Everything is zero, right? We'll flip it zeros to one. This is all ones. This is one. This is one, right?
Mhm.
So now what you will get? You're you're trying to add one with one. What is that? One. The
One.
entire bit will be one, correct?
Yeah.
So because we flipped it one, 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 one. You flipped the bits from zeros, ones to zero, and zeros to one. Okay. Now you're adding it. Now what you're doing, you're just adding it from here again. So zeros plus one is one. So what will happen? Based on addition operation, we don't have zeros and zero here. We just don't go by here. Okay. In addition part, what we're doing, we are flipping the subnet mask. So what we'll get, you'll get zero, zero, zero. Okay. And one, 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 one. And now this guy, you're trying to add with this value. Okay. When you add that value, you will get what? You'll get 10. Okay. And what?
Two five
Then
five.
255, 255, 255.
Yeah.
Making sense now?
Yeah.
Okay, cool. Right. So now that you have understood this, so only thing that you need to understand is like AND operation and add operation. And on top of it, where the AND operation happening. AND operation happens when you're trying to understand the network. Okay. Now, if you want to understand what is your, the broadcast IP, you're just doing the add operation. Okay. Simple as that. Cool. So let's go to the next slide. Yeah, this is what I just tried to make you understand what it is all about. Okay. We have the IP address, the annotation of the prefix is what? /8, right? What we did, we just gave that details. So this one is networks, this one is host bits. Now, out of that, we need to understand the networks and broadcast. That's what just I try to show you. Okay, just move to the next one. So I think in the last class we also discussed about the private and public IP as well, right?
Yeah.
Yeah, let's skip this. So only thing that you need to look into is the fact that your 127.0.0.1. What is this IP used for? This is typically used for your loopback IP address. Okay. So just try to understand what is loopback IP address. This this has not been used in your network, but
Mm-hmm.
but in a sense, better it will just take it a bit later on, not now. Just try to understand that in your networking environment, you have something called loopback interface. Okay. And you're giving this loopback interface on your router. Okay. And you're giving specific IPs to that. And why we are giving that? In case the router goes down or something, at least your virtual interface is up. Okay. Now just don't mix up with that here. This is totally different. We'll come to this later point. Let's just move to next guy. Okay. So we now figure it out how the conversion happens, right? There is one more thing called subnetting. So what is subnetting, right? So /24 means you're having a set of numbers of IPs. Okay, you don't want all these IPs to be consumed for one specific guy, right? So that is the reason you're just trying to segment it based on your requirement. Okay, assuming that you're having a slash 24, but you are like, okay, I don't want uh this number of IPs, a block of IPs to be used for one specific guy. I mean, the requirement for that guy is around 10 IPs. So what will you do with slash 24? Slash 24 is what? Is a huge amount of IPs, right?
Yeah.
So, so what will you do? You'll just try to subnet it. And how you do that? You just borrow some bits. Okay. So here it is like what you see. You're seeing that these guys have made it the slash 24 and the slash 27. Okay. So what that means? So slash 24 is what? 255, 255, 255. First three octet is your completely utilized in your slash 24. Now, when you convert to slash 27, what you're doing is you're just trying to borrow the 3 bits from the last octet. That is, here if you see 111 has been consumed. Okay, you're borrowing the 3 bits and you add that 3 bits and your new subnet becomes what? Slash 27, correct? And
Yeah.
and when you do the AND and or operation, I mean, sorry, AND and add operation, you get your network and host, right?
Mm-hmm.
So that's a long way. So I'm just giving you how things are happening here. So you have a slash 24, right? 10.0.0.x value, whatever it is. Now, in case if you want to segment it based on your requirement of slash 25, slash 26, 27, what the requirement that you have, or you want to reserve some IPs of slash 26, you can do that. Okay, either you can do it in 4 parts, that is, slash 26 or 4 slash 26 subnet you can get. If you do it slash 27, you can get it around 8. If you want to mix it up like slash 25, 27, or 26, you can achieve that as well using what? You can do it with subnetting. Okay, you can do that. So, yeah, that's all is subnetting all about. Okay, before that, class A, what is class A? We discussed in the previous class, what is class A?
Yes, sir.
So, can you just let me know what is a class A? 1 to 126 your class A. Okay,
Yeah.
128 to 191 is your class B. 192 till 223 to 223 is your class C. Okay, and by default, class A is your class slash 8 subnet. Class B is your slash 16 and class C is your slash 24. Okay. Now, if you combine that here, just want to let you know this is the number of IPs that you get. Okay, 2 raised to 24. Okay, minus 2, and you can see 2 raised to 16 minus 2, 2 raised to 8 minus 2. Okay, these are the usable IPs that you have. Now, how did we came to know that 16 raised to 16 some that lakhs of IPs are there and 65,000 IPs are there for 2 raised to 16 minus 2. And what is that minus 2 actually? So in a network, you do not include your network ID, network
And
IP,
broadcast. Yeah.
and broadcast IP. That is your minus 2 there.
Yeah.
Okay. Now let's come back to here. It has mentions 2 raised to 24. Now we learned all these things and just try to think what will be 2 raised to 24 here. These are the assignable IPs in class A. Class A is a slash 8.
Yes, sir.
Hmm. So what is that 2 raised to 24? Can anyone just try to think over it? You have the answers. We just spoke about it. Based on that, what do you think that 2 raised to 24 will be?
Sir, host address. I mean, the assignable IP addresses.
Exactly.
Yeah.
See, 2 raised to 24 is what? 8 plus 8 plus 8. For
Yeah.
slash 8, you have 8 plus 8 plus 8, 0, 0, zeros, right? You combine those three, you get 24, right? Now 2 raised to 24, those many IPs minus 2, that is the network and a broadcast IP, that is the maximum IPs that you get in that subnet, right? 16,000 something. Same way with the class B. Class B is 2 raised to 16 because we only have two host bits, two host octets, right? So that we are just 2 raised to 8 plus 8, that is 16, and minus 2. That much amount of IP is present only in class B. Okay, in class C, you have 2 raised to 8 minus 2, and that is we only have one bit, one octet free, and that is 2 raised to 8 minus 2. Okay, that how about 254 IPs? Let's just go here back. Okay, now tell me, you have slash 27. How many hosts do we have?
6. Oh, sorry. 24. Oh, 5.
So our value is 2 raised to 5 minus
Yeah.
2, right?
Minus 2. That's right. Yeah.
That is the total number of usable IP that we are having in that network. Okay. At least you came to know what is how we are trying to figure out the uh, total number of IPs present in a subnet. Cool.
That's right.
Why is Kunal silent? Is he able to catch up? Kunal, are you there? Okay, no worries. Right. So that's what we had just discussed now. What? Calculating the host, right? What it is? You're just managing, that is the formula 2 raised to h minus 2, and h denotes the number of host bits present. And you put that on top, and then you get that value. Okay. Now, now the next part is, um, now you want, this is what about your host calculation. The next part is calculating the subnet. You just do the reverse way. That is, okay, separate mask of 255, 255, 254, 224 is applied to class C network. Okay, then what is happening? Yeah, all right. So this guy, we created the number of hosts. Now that we need to know is how can we, this is a total number of hosts. So how many subnets we can create, right? That's our whole intention now. Now, as a US network engineer, you need to understand, okay, you have this much of IPs. I can get this much of IPs. And how many networks that we have? Right? You cannot just say the numbers, right? You need to give the exact number, IPs and networks as well, the total number of networks. To find that is the next uh, a challenge. Okay. Now, just go to this. You want to support 10, 100 hosts. 6 host bits are not enough. 7 bits are more than enough. Okay. So this is ideally, what it means is that similar to what based on your requirement. Okay, now you have a requirement of around, let's assume you have 100 hosts. You need to have 100 hosts. On the left hand side, you have the host bit that you have. Oh, sorry, host bit is 2, 3, 4, 5, 6 till 12. We have the 12 host bits. On the right hand side is the number of hosts that can be used. Okay, now the equation is your requirement is of 100 hosts. Okay, now since you have 100 hosts, out of this, which one will you look? A bit that can give you a 62 host, a bit that can give you 128 host. Okay. Now you don't have the number of exact numbers of 100. So in that case, you'll always go with one step ahead. That is the one number above. Okay. So in that case, what happens is you are using a host bit of 7. That is, in case if it is slash 24, right? You're just adding one more bit. That is what? what will happen is 225.225.225.128. That becomes your subnet mask. I'm pretty sure you might be confused here.
Yeah, a little bit.
So what here happening is, let me take my pen. We have a requirement of 100 hosts. Okay. Now, um, assuming that we have a /24 subnet. Okay. In that /24 subnet, you need to figure out if I add how many, if the number of bits if I add. So /24 is what? 1, um, 1, 1. So I'm just giving 1, 1, 1, and then zeros,
Zero.
zeros, 0. Okay. 1, 2, 3, 4. One more last guy. So this many zeros are there. So this is /24. Okay.
Hmm.
Now you have a requirement of what? You have a requirement of around 100 hosts. Okay. Now on the left hand side, it is saying that if you have this many free bits, okay, on your octet, you can get this many IPs. So if you have two host bits that is free, you can get two IPs. If you have three host bits, you can get six IPs. If you have four host bits free, that is just go like this. 2 means 2 here, 3 means 3 here, 4 like this, 5. Okay. So if we utilize 6 bits, you can have an IPs of around what?
62.
62.
Yeah.
Okay. Now, how did we got to that uh, value? 2 raised to 6 minus 2. Okay.
Yeah.
That's what's happening.
Hmm.
So here, if I have 7 host bits free, that is 2 raised to 7 minus 2. That is,
126. Yeah.
yeah, this many IPs are, or this many host bits are free. And that means I'm only consuming one host bit additional, right?
Hmm.
So what happens is I'm getting an IP of 126 usable IPs I can have. Okay. So what happens is till here 1.1.1, that is 255, 255, then dot one. This becomes your host bit again. So that is you're taking one more bit here. Okay. So that is your /25. Your /24 has become your /25 now. Correct? You're taking one, you're borrowing your one bit from this octet, last octet, that becomes it /24. Okay. Now
Yes, sir.
what? So what? Now what the subnet mask becomes? Your subnet mask will become 255, 255, 255, 128. And what is this 128?
That's the first uh, octet, right?
So we know that the conversion happens with the help of 128, 16, those values
That's right.
top
That's
of
right.
it.
Yes, sir.
So we are taking this one bit here. So
Yeah.
that means this is 128.
Yeah.
Okay.
One bit. Sorry. Yeah.
Yeah,
Of the octet.
that's the subnet mask you have. That is 128 is your subnet mask. Okay. Is this understood,
Yeah.
guys?
Yes, sir. Absolutely.
Cool. So now that we understood this, I'll just go to the next guy. Oh, sorry. Okay. So next slide, we'll just try to see how many network are we trying to create here. Okay. Now you have a subnet mask of 224. So what does 224 mean here? Okay,
Uh,
you're
128 plus 64. Oh,
correct. So your 224 means you're borrowing two more bits here.
two
So
more
that
bits.
is
Yeah.
128
32
plus 64. You're
plus
borrowing
32
this.
again.
Yeah. So that becomes your 224 here.
Yeah.
Okay. So how many host bits that we have? We have 7/16. 6 host bits are free. 2 raised to 6 minus 2. That's your host. Okay. Now we need to calculate how much is the subnet that we can create. Okay. Now in that case, what will happen? Your class is C. okay, because we are having a subnet of 192.168.1.0/24. Now we are converting it to /20, what it is, 26, okay,
No, 27, sir. 128
120.
plus 64 plus 32, 224.
Okay. So sorry. Thanks for correcting. So that means it becomes /27 here. So what we'll do? So we need to convert this guy into /27. So how many subnets that will be created here? New subnets will be created here. So what we'll do is how many borrowed bits? 2
3.
raised to 3. So we have borrowed 3 bits. That is
Mm-hmm.
128, 64, 32. So 2 raised to 3. That is what? 8. You have
8.
8
Yeah.
subnets. Okay. How do we verify that? We just verify. This is something we have called a subnet calculator in online. I just took that
Yeah.
value here. So what we'll do, you'll get these ranges here, right?
Yeah.
1.0, 1.32, 1.64, 1.96, 1.98. So around how many? 2 raised to 3, 8. That is 1, 2, 3, 4, 5, 6, 7, 8. 8 subnets we are getting in this new /27 range. When the /24, you are cutting that to, you're making it to /24, you're getting 8 new subnets on this, right?
Yeah.
Now, so this is what we have done. Now we are trying to understand, okay, we have network ID, we have broadcast ID, we just first hop IP address, last hop IP address. We discussed all this. We discussed how we are calculating network ID, broadcast IP, and all, right? So now our next part is how we are trying to identify 172.20, first IP and second IP. That is what we're trying to understand it, how we're getting those first IP and all. Okay.
Mm-hmm.
So, okay. So let me see. Okay, so this is the last thing. By this, you'll be able to complete the entire thing of IPv4. So
Have you done with CIDR? That's what we are doing, right?
this
CIDR?
is this is what we're going to do.
Okay.
Then we have the network summarization and then determining the size. Okay. So in every IPs or every network IP, right? There is one specific IP which is changing. That is your interesting octet or interesting thing or interesting or which is changing time and again. Okay.
Mm-hmm.
So now so you have seen this, right? 1.0, 1.34, 1.64. Now we need to calculate now how we're getting into this IPs. 1.0, 1.32. We're just trying to figure it out. That is what we call as a block size. Okay. Now block size is what? That is that is 256 minus your interesting octet value is what your first block of IP will be, right? So here, if you see here, we know 1.0 is our first. So 1.0/24, right? That is 1.0/27 is the first. 1 second. Sorry, guys. Okay. Now, in the previous thing here, we know that 1.0/24, right? So
Mhm.
the first IP is what in slash 27 is 1.0/27. Okay. Now, what we'll do, we need to find out the next IP block, right? So we have 1.32 here. So now, how do we do that? So in our case, uh, what we need to do is that whichever is your interesting block, right? So here in this case is um, this is what was trying to do here. This is /16 here. Okay, so 172 to 225.0.0 is your /16. Now you're making it a /24. That when you're making it a /24, your interesting octet becomes your third octet. That is, this guy is becoming your interesting octet here. Okay. Now in that case, what happens? What you do is 256, okay, minus your interesting octet is of third. So what is the value you have? 255. You get a value of 1. Okay. Now 172.25.1.0. That is your next. Then you again add dot plus 1 on this third octet. That is 2. Okay. Now you again add till 255. That's the your interesting octet value that is getting changed here. And you're getting the newer block of IPs here. Okay. Similarly, if you go here,
Yes, sir.
one second. So similarly here in this case, we have what? We have a /27. So our interesting is what? Interesting value will be what it is. To 128, that is 224, right?
Yeah, 224.
224. So 256 minus 224 is what? Let me just calculate. 256 minus 250, 224. 32. Okay. So
Yes, sir.
256 minus 32. So next block of IP becomes 32 here. Okay. Now
Yeah.
what you do, you just add another 32, you get around 64. Add another 32, you get 96. Another 32, you get 128, and so on and so forth it goes. Okay, so 8 till, because we know that we only have around 8, we'll go till around 8. So till 224 we'll get, right? And also we know that our block of IP is /24 /27 is 224. Till last 224 will be able to reach. Make sense?
Yeah.
Okay. Now you got to know, right? Uh, which is your network, 8 networks you have. What will be the first usable IP? You just add 1. You get have the 1. Uh, that is your 1.1 becomes your what? Your first IP.
First
Okay.
host.
Yeah. And what is your broadcast IP in that? One IP, one IP less. That is 32 is the new network. One IP less is your broadcast. That is 31. Now you have another way as well. The first thing that I told about the and or operation, sorry, and an add operation, you can do that, or by just by calculation, you'll get to know here. Okay, that is
Yeah.
1.1 is your first IP, and dot 30 is your last IP. 31 is your broadcast. So first and your last. First is this first IP of this network is what? This is a network. That is a network, and the last IP dot 31 is your broadcast IP. Correct? So based on
Yes,
that,
sir.
you're just calculating everything. Okay, till here it is making sense.
Yes, sir.
Okay, so in the last case, the last IP, that is 192.168.1.224 is the network. Okay, so in the last network, what is the first IP? Plus one, that is 225. What is your last broadcast IP of this? What's the broadcast IP? You can only have 255, right? So this is the 255 that you're having. Okay, beyond that, you will not be able to go, right? Your that is your broadcast IP, and 254 is your last usable IP. Okay, cool. Makes
Yes.
sense.
Yes, sir.
So that is what it is saying here, is similar to what we covered, that almost everything. Okay. Um, there's the same thing in the counting. Okay. Now uh, now we know that we can split the IPs as well. Okay, based on your requirement and whatnot. Now there is something called summarization. I mean, if anyone who is very good in summarization, uh, what what is a summarization? We just now we split one subnet into multiple subnets. Okay. What is summarization? What do you mean by summarization? Anybody?
No,
Eh,
sir.
Okay. So summarization basically means, so let's assume you have, okay, you have this much amount of IPs, 1.0, 14.0, 25.0, 30.0. Okay. Now you are on one end of your router, your entire enterprise is having this many subnets. Okay. Now you need to give, either you can give all this subnet again and again and again. Okay, the other guy will be using all the subnet. Or the best way is that you can summarize all this and you can give a supernet to the guy other end. Okay, that is what the summarization is all about. Okay, what it'll do is, so here you can see here, so we have 192.168.1. Okay,
Mm.
192.168.14, 192.168.25, 192.168.30. Okay, now when we convert all these IPs into binary, right? You can see till octet 3, first 3 bits are same, right? After that, the change happens. See, here if you see 30, till here the change is happening, okay? But the first 3 bits in that octet 3 is same for all the 4. Now, what you do in this case, okay? You can summarize that, okay? And then you give it to, what will happen? The first 3 bits you're making, you're just giving it as what?
Network, sir.
Yeah, no, no. So here, see, so here what will happen is till octet 3, it is same. However, we have the slash 24. Okay.
Mm.
So you can summarize all this together into bigger network, right? So what it will be? Slash 23 or something like that? Just try to think of it.
Yeah, it's showing 19, sir.
Yeah. That is the first 19
Yeah,
bits. So what will that be? What will be the subnet mask will be for that?
sir. 255.255.224.
Right. So that subnet you can summarize, right?
Okay, got it. Got it.
So because that is constant there, you can summarize that. Okay, that's what it is happening. Okay.
Got it, sir.
Okay. So, but in IP, the thing that you need to understand in IP, you can just summarization is something you can do it, you know, uh, uh, not will come into that picture when you're working as a new guy. But the thing that you need to understand is the how the subnetting is happening, how you are splitting the subnet. Okay, because that will come more than the summarization part. Okay, summarization will not be coming more, no, because as a network engineer fresher, you just need to understand what IP what it is. Because still when it is straightforward slash 8, oh yeah, slash 8, right now this is 255 or 0.0.0. Okay, slash 16 is this much, slash 24 is that much. But when you actually, when you see like 10, 23, 27, like that's when you just can face, okay, what will be this broadcast IP and stuff like that. So to get that, you need to understand this. And the important formula is, right? Make note of the CIDR, I mean, not the block size. Okay. How you're calculating the block size, you need to be thorough with this. And the next part is the 2 raised to 3, that is 2 raised to S, 2 raised to subnet. How you're getting that value? Total number of subnets, and the 2 raised to H minus 2, that is total number of hosts you will get in the this one. Why? Because you will end up in a situation that you are most likely you're having a DHCP IP, and probably your guy is getting some IPs, but it is not, and or your DHCP is giving some IPs to your client, but for some reason it is not releasing that IP. Then you'll get to know, okay, this is a /27 subnet, and doesn't have that much IP. Then you need to again increase that. So in such kind of scenarios, it is the shortcutting to raise to H minus 2 will give you a much better understanding of how it is happening. Okay. So that's why these three formulas just keep in mind, and no, because subnetting is what you will be having working more in the networking environment. Okay, summarization is something that is comes in design perspective. You will not be looking at, but a- at least you just try to make sure what is happening in the summarization part.
Sure, sir.
Okay. Okay. Right. So IPv4 is done. Any questions so far, guys? I see new people here. Let me ask them some questions with the new people. Oh, rest of the
Sure,
people are
sir.
left. What happened? By seeing the IPv4 only, they got confused. Huh? Anyways, okay. So yeah. So do you have any questions on this one? Anything, or is it all good?
No, Vivek, sir, all good. Yeah.
Cool, cool. Right. So let me check. What do we have today? So this is one big part. And IPv6 in CCNA is not that much. You can just have a very base thing. That's the reason I've kept it at the last. Um, Let me see. Okay, IPv4 is done. The next class, on the previous class, we tried to see how the router is getting booted and what is Roman
Yeah,
1.
yeah, yeah.
We checked that, right? We also completed that. Okay.
So, Vivek, sir, what will we have tomorrow?
Yeah, we have classes tomorrow. Why
No, no,
don't?
no. No, the subject.
Yeah, for IPv4.
No, yeah. What will be the topic tomorrow?
That's what I'm just trying to see. So we have done OSI model, we have done address and topology, network types, we have done. So we have done the router modes as well, right?
Yeah.
What is the router? Okay. Tomorrow, what we'll try to learn is we'll try to understand how the flow of packet works, ARP, how DHCP works, and how the this thing, what is it? What do you call it? The how the packet have switching happens, ARP, frame, then packet, how it is happening in the same network and different environment, because that is very important. And if you don't get get a hold of that, you will be screwed in your interview, because even if you have done many configuration change in your network environment, when interview comes in, no, he will ask only this. Basically, he will start from this, and from there he will catch hold of your network base. So uh, till here it is like a cakewalk. I mean, people might ask, people might not ask. That's okay. But this thing, tomorrow's topic is something that they will ask for sure. How how ARP is working, how the frame is getting forwarded, how the packet switching happens. Okay, how it packet switching happens in two different what do you say subnet masks and same subnet. So all these things we'll look at tomorrow. Okay, we'll get a more in detail how it is working, how the packet is actually working in our networking environment, which is very important. Okay, so if you get hold of this, I mean, in 50% of your interview, you cracked it. Okay, based
Wow.
on your experience, I'm saying. Okay, so if you have 3 to 4 years experience or any number of experience, this is something that they ask time and again. Okay, so you need to be thorough with this. Okay, and from there you build up these certain because this, when you understand all this concept, then you build up the next level of your knowledge. Okay, how the routing is happening, how this is happening, how that is happening. So from there it is build build up. Okay, if you don't have this, even if you have some, because um be- any new kid who is new to computer or everything, if you give the commands, like, he will be able to do it. You can just go and blankly configure that device, it will work. But what is happening in the background is what we need to understand. So we'll tomorrow we'll get to know how that's happening. Okay.
Sure, sir.
All right. All right then. We'll see you tomorrow. I hope this session for today was good and you were able to understand that. So we'll meet
My
up tomorrow
pleasure.
then.
Sure, sir. Take care.
Thank you.
Thank you, sir. Bye bye.